Regular expressions can be represented as DFAs. This is just the proof in the pudding of things I've said before. So here would be the regular expression of our A dot, and you notice all the symbols. And again, as you know, I'm going to read that from left to right. This is the DFA of that regular expression. You're going to notice some things that are frankly, well, they're going to make sense, and there's so many other things I'll have to explain here. So first of all, you know where the start state's going to be. We know that part. There are states that don't have labeled, but I really should. But there's one that's really important, and that says sync, by the way. That's called the sync state. I bring that up because there's going to be, as you know, a lot of different variations of this that frankly we know already that, hey, there's no recovery from it, and it's not going to match. That's what the sync state is supposed to actually catch. It's called an error state as well. You've heard of error state in other computer science genres before. So if we are not given an A, then instantly we have an error. So you'll notice that's exactly what we have is if there's an A, then we move on to our next state. But if it's not an A, we go straight to the error state or the sync state. That's done because we know there's no recovery from that. Then it can be any wild card. As long as it's not epsilon, then we can move on to the next part. If it is an epsilon, remember epsilon means no value. A dot means a value, just means any wild card of a single value. We can move on from there. So notice that each state has a repercussion. Either we're given what should be matching, or if not, we go right to the sync state, and well, that's where it's going to stay and lie because we got a problem. The interesting part is doing the B's and C's and the groupings, and then we have our plus behind all that, which means a lot of different, combinations that we can have. So that's why you have, it looks like a clover leaf here with all the bunch of leaves and stuff like that. So that's how we can get to that. And then finally, when we're done with either getting a B or a C in there, we can be done with it and end up at our very, very, very lonely except state at the very end. And notice that I'm going to try it out with different combinations as well. So try this out. See if there's something wrong with it and go from there. But notice this is just the drawn out representation of what we did previously in a set of notes here. Here's some simpler versions of it. I'm just showing you if we were to accept an A. We would go from the start state. We would have an input state or input edge of A to go to another state. A and B together. This is actually just trying to really show you the combinations of things that you would have in regular expressions, and then it gets more complicated from there. But that's how we can represent regular expression with DFA. So to be honest with you, personally, because I'm a visual person, I actually start with this and then try to realize, wait a minute, I got a whole bunch of combinations, so I can start making the regular expression from there. So just again, another tool to visually represent what we can do with regular expressions. And then again, we're using the regular expressions to then parse what we have lexically. It's a big process in many ways.